So this is part one of our two-part series presenting our team presentation. My name's Caleb Woolsey. I'm going to be doing part one and going over a portion of the team presentation and going over the individual part. And Brett Silva is the other member. He's going to be doing part two after my presentation is done. He will be taking over and doing the second part of the presentation. So our game in a nutshell is the Tree of Life. It requires the user to answer certain questions. These could be mathematically complex questions. They can be scriptural questions, moral questions, things like that. And by answering these questions, they obtain the armor of God, which then allows them to progress in the game towards the Tree of Life or immortality, which is what the Tree of Life symbolizes. So let's go into the my portion of the team presentation. So Brett Silva will be covering the three functional layers of the program and what they're responsible for. These would be the model, control, and view, and kind of what those do. But my portion, I'm going to be covering the attribute, method, class, and object instance, and kind of what those are. So let's just get into it. So what is an attribute? An attribute is basically just a variable that's held within a class. So a class, now let's talk about a class. Let's start there. Let's start with the big stuff and work our way in. So a class is basically a sort of a library. A good example of this would be the string. When you use the string variable within the Java programming language, you have to implement a certain class. Someone created this class and you're implementing it in order to create a string, which is just an array of characters organized in a fashion. So this class is a generalized thing. So when you create a string, that class isn't your string, but it's a generalized way of describing that. So now let's get into the object. What is an object? So an object is a specific instance. So we can think about this as a player of a game, right? So if we were to define a player class, it's a generalized, broad description of what the player would be. What does a player have? Well, he has a name. He's got, let's say, a record time for our you can see later, our implementation of player. So if you have 4 players, player 1, 2, 3, and 4, all of those are still a player class, but they're separate instances of that, or separate objects. So there's player 1, player 2, which are both separate objects, player 3 and 4, etc. But they are all still within the player class. Now, an attribute is basically just a variable held within the class that's private. It's kept away. It's not secret, so to speak, but it is protected within that class. And the only way to get access to that attribute, so name, so to speak, would be through a getter or a setter, which is a method. So what is the difference between a function and a method? A function is a way of separating code that's called from another part of your code. Well, when you take that function and put it inside of a class that only that class can run, well, then it becomes a method. So when you use a getter or a setter to get information from your attributes of that class, you're actually just using a method. So those are what the attribute, method, and class and object instances are. The next thing, now it kind of goes into the individual base. Each team member will be covering this, so you'll notice a lot of sort of repeat between me and Brett. We wrote different code and things like that, so we'll be going into the different code and UML documents and describing kind of what we did. So the first thing it asks us to do is to describe the attributes and methods defined for 2 different classes of our UML document. So let me bring that up real quick here. Okay, so this is one of our UML documents that we created. This is the control layer UML document that we created. And as you can see on the top left, or maybe the top right, I'm not sure for you guys. In my side, it's the top left, the player. Each one of those blue boxes is a class. So let's look at the player. You can see the name and record time. Those are attributes. When it's a minus, it's an attribute. When it's a plus, it's a method. So the name and record time, those are private attributes. They're held within the class, so name and record time. Well, how do we get access to the private variables? Well, we have getters and setters, such as you can see there, get name and set name. Get name will return the value of what the name is storing, and set name takes a parameter of name to pass in, or takes in an argument to pass in as a parameter, which will then set name to whatever was passed in. Same thing with get record time and set record time. It does the same thing. Now if we look at map, we can look at the attributes, which are row count and column count in the center of the screen there. Again, attributes, and get row count, set row count, and you can't quite see it because my video is in the way, but it says get column count and set column count. It does the same thing that player does. So if a player was like, hey, where in the game, let's say they wanted to know where they were on the map, so the map would then say, okay, well, if I need to know where they're on the map, well, what do you need to know? You need to know the row count and the column count of where they are. So the game would then say, okay, let's get row count and get column count. So you get your northing and your easting, and then it would figure that out on the map and say, okay, you're here now. So that's kind of how methods and attributes would work for those two things. The next thing it talks about is, for us to describe, is the difference between dependency and association relationships. So as you can see here, these arrows in the middle between game control that points towards player, game, and map, those are dependency relationships. So game control, which is kind of how player, game, and map interact with one another, save game, start new game, stuff like that. Game control cannot be implemented. You can't use a game control, the method start new game. You cannot start a new game if you don't have the game class. So what that's saying is the game control class is dependent upon player, game, and map already being created, or not created, but already being defined. Someone can create a map, player, or game object that will allow them to then use those objects to use the game control. So for instance, in game control, if you had start new game, if you tried to do a start new game and you had no idea that you hadn't defined a game class yet, you wouldn't be able to do it. The program would be like, I don't know what start new game is. I have no idea what that is. So those are dependent upon player, map, and game to be predefined. The next thing is association. I'm going to bring up our other UML document. This is our UML document that goes over the model layer, and Brett will describe what the model layer and control and view and all of that is. So this is our UML document for model. If you can see on the opposite side of where my face is, I'm not sure if that's left or right, you have player and game, and you have a little line there, and then you have little numbers, and what do those numbers represent? Well, those numbers represent what's called cardinality. So you have a player and a game. Well, the association relationship, you can have 0, you can have 1, you can have many, and those numbers define how many of those things you can have. So for instance, if we look at game and then player, so let's look at those two there. So game, how many players can a game have, right? How many players per game can you have? Well, it depends on the game. Unfortunately, in our game, we don't have a multiplayer setup yet. So in our game, we can only have 1 player per game. So for every game that we have, there can only be 1 player playing that game, that specific game. However, if you look at it on the reverse side, a player can have 0 games. A player could create an account called, player 1, and then player 1 could just sit there and not play any games. He doesn't have to play a game. However, that doesn't mean he can't play 15 or 20 or 40 or 400. He can play as many games as he wants. So that's why the relationship between player and game would be 0 to many from player to game, because the player can have 0 games or he can have many games, whereas the game can only have 1 player per game. And it's a requirement to have at least 1 player. So at least and at most 1 player per game. So that right there kind of defines the association relationship between game and player. It goes for all of the other ones as well. Game and armor, you can have 0 armor pieces or 6 armor pieces per game. You can only have 1 game per armor piece. It's things like that. So you have to have a game in order for the armor to be implemented in that game. So that kind of goes over the association and dependency relationship that I defined there. So the next thing that this team presentation requires us to go over is a Java bean. What is a Java bean? What makes a Java bean? And for that, I'm going to pull up my NetBeans real quick here. Let me see if I can do that right quick. NetBeans. Okay, so this is my tests. So let's go into, what is it, armor, I believe? Yeah, so here I kind of made some notes for myself, a little note card. So in order for a Java bean to be made, what defines a Java bean? Well, a Java bean, one, implements serializable. So right here, you can see the implements serializable function, which then requires you to import the java.io.serializable up here. And if you do this, if I was to take this out, let's see if it will do it. Right here, it's like, hey, I can't do this. All you have to do is click that and add import for Java IO serializable, and boom, it works. So that's one thing, one of the 3 steps in order to make a Java bean. The next thing is it must have a default 0 argument constructor. So basically, when you go to implement an object of this class, if I just say, if I don't pass in any arguments whatsoever, it should be able to create a blank slate. What it does is it says type, description, name, and category. All of these things will be set to nothing, to blank, because the 0 argument constructor created a blank slate class or object from the armor class in this case. The next step is 3, has getters and setters for every attribute. So type, description, name, and category, all of these are private attributes. And all of these things in this class have getters and setters. If I scroll down here, I got get type, get description, set description, get and set name, get and set category. So all of these things have getters and setters. That right there is what makes a Java Bean class. Now there's 3 functions, or methods I should say, as it's more correct, 3 methods that is recommended to be implemented in a Java Bean. Now these are toString. You can see here the public string toString method, and what this does is it simply returns the class name, and then it says it will return the type, and then return the actual value of type. So it will return the name of the attribute and the actual value of that attribute and display it out to the screen. So it's really good for testing purposes to see if you're passing things incorrectly. You might actually use it in the actual game that you're implementing, but it is really helpful. The next thing is hash code. I personally have not used, or I know what the purpose of a hash code is, but I haven't personally used it because I haven't created a data structure or a hash table, things like that. But basically what it does is it creates a single 32-bit signed integer value, which is a hash, in order to create data structures, hash tables, things like that. Hash tables or hash code is often used to secure data in a database, to make sure that if anyone hacks into the database, that it remains secure, that they can't receive the actual information, but they receive a hash code that they have to try and debug, and it's really hard to do that, or not debug, but decipher, which is really hard to do. The next thing is equals, and what the equals does is it basically will determine if I say armor equals, or if armor double equals armor, then this. And what that says is it will, like, is this object equal to this object within the armor class? So it's a way for me to compare 2 objects of the same class and say, are these equal? Are they equivalent? And basically what it does is it says, is the type of object 1 equal to the type of object 2? Well, are they? Great. Is the type of description, or is the description here, this variable here, equal in both objects? And if it is, it goes through the whole thing. If they are exactly equal, then it does whatever the code is. So it's a good way of testing to see equalities between 2 objects. So that is, let me go back to our instructions here. So that would be the way to implement a Java Bean. So now each team member is to use an example of code they wrote to demonstrate their understanding of variable scope and lifespan. So let's get into that real quick. Let me bring this back here, and NetBeans. Okay. So variable scope and lifespan. So let me find. There's a lot of classes here and things. So let me find one. I had one. I don't remember where it was though. Is it armor? Maybe it's armor. No. Where was it? Yeah, perfect. This one will do great right here. So this right here, void display menu. So the char selection, this defines a variable called selection that's just blank, right? and then when it calls the get input function here, which will get input from the user and reset selection. Right here, selection equals input.char at 0. So it's going to take the first character that the user input to the keyboard and set that to selection. Then when I call the do action and pass in the selection, so down here when I call this function here, if I was to change choice equals, let's say the letter A, when actually the user input the letter B. So up here in my display menu, the selection would still be B. Even though I changed the choice here to A, doesn't matter, because choice only remains A within the do action method or function. As soon as I return or break out of this right here, as soon as I return out of this function and it comes back to my display menu function, my selection remains what it was before. So let me get rid of that so I don't keep that. So that's the scope and variable lifespan. The variable only stays what you set it as within its own function. As soon as you return out of that function, it returns to the value it was previously, unless it is called by or passed in as a pass by reference. If it's passed in by pass by reference, it continues to hold its lifespan, which can be confusing. If you do too much pass by reference, it gets confusing as to, well, what is it here? Is this pass by reference? Is it not? Is it pass by value? Things like that. You have to be careful with that and memorize where things are going. It can get really complex with thousands of lines of code. So yeah, let me go back here. Next part that I'm going to be talking about is demonstrating how argument values are passed to a function. Then I'm going to be going into primitive data types, mathematical and relational operators. So let me bring it back to my NetBeans code here. Okay, so the first thing that I'm going to be going over is how a variable is passed to a function. So for instance, when I call this dot-do action, it's saying in this class here, in my public class help menu view, I'm going to call the do action function, and I'm going to pass in the selection variable, which we know back here was set to null, but then all of a sudden here it was set to whatever the user input. So let's say the user inputs a capital A. So what it's going to do is it's going to pass in a capital A to the do action function. So the do action function down here says, it says, okay, so when I define it, I'm going to say char. So I know that the incoming value is going to be a char. If I pass in a 2, it's going to be like, whoa, I can't do any math with this. It's a character. And it's going to say choice. So I'm changing from selection to choice. Just for my brain, it works a little bit easier. You can keep the selection name or you can change it, doesn't matter. So it's going to say whatever was passed in, it better be a character. If it's not, the program won't run. And then it's going to say, okay, it's going to be called choice. And then I can use that variable, which was before selection, which is now choice, to do whatever I want to do in the program. Now I'm going to be going over relational and mathematical operators. So let me find a function in here that uses mathematical and relational operators. There's do while. Is there an if? No, there's not. Where's my if statement? Is it here? Here, perfect. So this if, else, all of this stuff. So this is going to be a Boolean operator here. This here would be considered a mathematical operator, the plus there. So in a program, you've got mathematical operators and relational operators, or Boolean. So it's going to say times asked here. So let's go over relational first. That's pretty easy to cover Boolean. Times asked. So what it's going to say is, what is times asked equal to? Well, we define it up here to 0. And then it's going to say if times asked is less than 3 right here, then that's going to evaluate to true. If everything in this evaluates to true, then it's going to run. So this is a double ampersand, which is an AND operator. So it's going to say if loop is not equal to 0 and times asked is less than 3, then we'll go ahead and run another loop of the while. So what I've done here is times asked is less than 3 the first time, so it's 0. It's going to run through blah, 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 and then all of a sudden, as soon as it hits here, times asked plus plus. So now times asked goes up to 1. Then it's going to run through again. Well, 1 is still less than 3 up here, so it's going to run, assuming that this evaluates to true. Then it's going to be 2, then it's going to run again because 2 is still less than 3. But the third time, after it runs through 3 times, times asked now becomes 3. Well, 3 isn't less than 3, it's equal to 3, so it won't run. So that's kind of a relational operator there. Let's see. Mathematical operators, the plus plus. This is a mathematical operator. There's plus symbols. If I could do times, I'm not sure if times equals. I could do times equals times asked, which would just say times equal or times asked equals itself times itself as well. So if it was 2, it would be like 2 equals 2 times 2, which would be 4. If that makes any sense. It might be a little confusing, but yeah, so there's a lot of different mathematical operators as well. Primitive data types would be an example of an integer, a float, things like that. So int, that I didn't have to import anything in order for int to be recognized. It was just by default recognized. Whereas if I was to use a string, I would have to import a separate class, as I mentioned before. The next thing I'm going to be going over is my knowledge of if then else, if ladder, and switch statements. So these are a little confusing, but they're really not once you understand them. Right here, prime example: if, else. So it's going to say it's going to run through the while loop. Once the while loop's done, it's going to come in here and say if times asked is equal to 1. Be like, oh, congratulations, you got the question right the first time. If the thing was to ask them less than 4 times, because remember, once it hits 3, it stops iterating. So as I described before, times asked plus plus reaches 3, not 4. Once it reaches 3, then the else if, it's like, oh nope, you're done, no more. This times asked, the while loop won't iterate it anymore. So the else if is less than 4, then it's going to say, well, you got the right answer, but it took you too many times to get it. Sorry. So if this evaluates to not true, then it's going to say, well, what about this? Does this evaluate to true? And let's say it does, then it's going to run this. Then the else won't run, and the if won't run. But if this also evaluates to not true, then it's going to say else. So if this is not true and this is not true, then this has to be true. It will run this every time if these two evaluate to not true. Okay, so that's kind of the if, else, ladders and stuff like that. The switch case statements, let's see if I have one of those. I believe I have one of those in, was it main menu? Yeah, perfect. So the main menu requires a user to enter the selection. It will display this menu and say, what do you want to do? So if the user inputs an N or a G or an H or an S or an E or whatever it is, then it's going to come down here and it's going to use the switch case statement that we talked about before. It's going to pass in choice. And if it's an N, it's going to run this. If it's a G, it's going to run this. If it's an H, it's going to run this. And this is basically a much faster and much more efficient way of writing code than if I was to say, let me get this here. This is the same thing if I was to write this code. If choice is equivalent to the character N, then run this code here. Else if choice is equivalent to the character G, then then run that code. Else if, and it's just a giant if, else if, else if, else if, else if, huge statement. Every case would be an else if, but the switch case statement is much more efficient to run than running a billion else ifs in place of that. So that's what a switch case statement does. Now I'll be going over while and do while. I kind of described that a little bit. So while will run, you know what, I'm gonna cover the differences between a while and a do while. There's also a thing called a for loop, but we haven't gotten into that yet, so I'll leave that for later. The while loop will run, so it's gonna test it first. It's gonna test is valid, not true. If valid evaluates to false, to not true, then it will run this. Whereas a do while loop will run the program or run this stuff first one time, and then it will test. So I have one of those. Let me see where that would be at. Is that here? Yeah, right here, do while right here. So instead of testing if selection is not equal to E first, it's going to say, okay, well, first things first, we need to get the selection first. So we're going to do this and then test it. and then if it still evaluates to not equal to E, then I'm going to do it again. So do while is a while loop. It just does it first and then tests it, whereas a while is a preemptive testing. So yeah. The last thing I'm going to do is run through the JUnit testing that we ran through, which I had to actually fix quite a bit of code because we changed a lot of this after the test assignment was due. So I'm going to be running through this here. And I actually realized that me and Brett, we did separate complex questions. We actually got graded down for that because it wasn't complex enough. But I realized something that I could have done to make it more complex. But after going through our tests or our functions, I realized that we both individually did the same thing. So calculate complex question 2 and 3, those are the same thing. So me and Brett are going to have to sit down and go over that and figure out something else to do. However, for the time being, basically what this does is it creates, it prints the line. This is the calculate complex question. So it's saying, hey, this is the test I'm going to run. It creates a double for the correct answer, which should be the correct answer, int height length 5. It runs this, creates a new instance of that, and then the expected result. So what am I expecting to get back from when I run the instance.calculate complex question, passing in all 3 of these values? So what do I expect, or what do I get back versus what do I expect should be the result? So if the result here is actually a 0, which is what my expected result is, then it's going to say right here, is expected result here equal to the actual result here? So that's what assert equal does. So when I right click this and run a test, it's going to test that. So all tests passed, right? And basically, let me go back to here. So what it does, let me go into the calculate complex question so you guys can see that right here. So, or here it is. So it's first going to test for invalid inputs. So if I was to pass in a 0 for either height or length, if it was a 0 for height, that would return a -1, which I could output to the user. If it was a length of a 0, it would output a -2, which is not my expected result, mind you. But those would be invalid. Those would fail the tests. Unless my expected result was a -2, which is still a fail, but you know. And then the double test answer. So basically what it does is it takes their input of length and height and creates a test answer. After the test answer has been created, then it's compared against the correct answer. If it is the correct answer, it returns a 0. If it's not, but it hasn't reached the invalidity, so if it passes the invalidity of returning a -1 or a -2, but it's still not the correct answer, then it's going to return a 1. So if a 1 is returned, I know that the inputs are valid, however, it's not the correct answer. So yeah, that's calculate complex question, and that's the control test to run that. So the next part of this presentation will be Brett kind of taking over, showing his code, what he did. A lot of the same things of what I just talked about is just him implementing his description and explanation of what they do, as well as something that I missed to describe, which was as a team describing it, so he will be covering that, is the 3 functional layers of the program, which are model, view, and control, and he'll be describing what those do and going more in depth with that. So I hope you enjoyed the presentation. I hope you got some valuable information on kind of where we are with our program and our knowledge of the Java programming. It's a complex programming language, but if you work with it, it works for you. So hope you enjoyed it, and look forward to Brett's presentation. I'm sure he'll do a good job. I will see you next time.